Hello and welcome to the 19th episode of Simply Electronics Basics. Today we're going to look at half-wave rectifiers. If you've watched my previous video, you've likely seen this circuit, which is the full-wave rectifier powering some LEDs. The full-wave rectifier consists of 4 diodes, which directs the current from both halves of the AC wave into a straight DC current. But there is a simpler configuration to rectify AC into DC, and we can do this with a half-wave rectifier. A half-wave rectifier consists of only one diode and makes a much simpler circuit. With a half-wave rectifier, if you keep your eye on this AC wave, you can see that current only flows on the top half of the wave, but does not flow on the bottom half of the wave. In effect, we have cut out one half of the wave, so we are only using one half of the AC wave. Half-wave rectifiers produce a less stable DC voltage. If you look on the graph at the top here, you can see that because we are using a half-wave rectifier, we are essentially losing half of the current flow because these gaps here are not filled in by the second half of the wave. So this produces a much less stable DC voltage, but it's still usable in applications that don't require such a stable voltage. For every full AC wave, I'm getting half of the wave in the form of DC. It becomes much more difficult to smooth out this current. I can try and smooth the current out by putting a capacitor in parallel with this LED to try and keep it lit during the time that current is not flowing. But as you can see, I've added a capacitor, but because there is more time where the current is not flowing, the capacitor drains before there's another supply of current from our rectified supply. So I've now got on the graph above the current flowing through the LED, so we can monitor how smooth this is. And you can see it's definitely a lot less smooth than it would be if it was being powered from a full wave rectified supply. So I've managed to smooth it out a little bit more because the capacitor is now not fully draining before it gets the additional DC supply, but it still could be much better. If we go back to the full wave rectified circuit, you can see that this is much smoother because the fluctuation is only between 13.5 milliamps and 15.5 milliamps. So there's a 2 milliamp fluctuation here, which means the supply to the LEDs here is quite smooth indeed. If we go and look back at the half-wave circuit, there is almost a 15 milliamp fluctuation, and I've even got a slightly higher capacitance. So it's definitely much more difficult to smooth the circuit when you're only using a half-wave rectifier. It is now very uncommon to use half-wave rectifiers unless they are specifically needed in special applications. So I hope you learned something from this episode. Make sure you subscribe to the channel. You can also go back and follow the Simply Electronics Basics playlist. If you do have any questions, leave your comments below. And if you like the video, please give it a thumbs up.